All right, so now we're going to look at another precinct somewhere else. This would clearly not be Williams County. 81% of the voters are registered Democrats. What's the probability that in a random sample of 100 voters from this precinct, no more than 80 of them would be registered Democrats? Okay, so 81%, that is our P, and we are looking for our P hat is out of those 100 voters, we want to know, no more than 80 of them. So our P hat is going to be 0.8. So let's draw this just so we can get a good idea of what's going on. Okay, so P is 0.81, and we are looking for in the sample, what's the probability that no more than 80%? Okay, so we are looking for this area below 80%. Okay, this time we're going to use our calculator to do this. So this is going to be a normal CDF. Your lower bound is going to be negative infinity. Upper bound is 0.8. Mu is 0.81. That's your P. And then sigma, you need to put in your adjusted sigma. You can put this all into your calculator exactly the way we did before. So let's see. P is 0.81, and then 1 minus 0.81 all over 100. Okay, and you can put it in there. The calculator will do the calculation and then finish off the problem. And when you do that, the calculator should say 0.3994. All right, let's check out another example. It is estimated that 8.3% of all Americans have diabetes. Suppose that a random sample of 74 Americans is taken. What's the probability that the proportion of people in the sample who are diabetic differs from the population proportion by less than 1%? And we're going to use our calculators. Desmos does this too, but you guys all have calculators, so it'll be fine. All right, so estimated that 8.3%. That is from the population. That is P. So we have a random sample of 74 Americans. That's our N. We want to know what's the probability that the proportion differs by less than 1%. So when I draw this, we know that the middle is this 0.083. And we want to look at 1% different. So up to 0.093 and down to 0.073. And we want it to differ by less than that. So we're going to be shading in between those two. So this is what we're looking for, is that region. So we're going to go ahead and do this on the calculator. You're going to go to normal CDF. Your lower bound is 0.073. Upper bound is 0.093. Mu is 0.083. And then sigma is going to be that adjusted sigma, P, 1 minus P over N. So 0.083 times 1 minus 0.083 all over 74. And again, you can just put that all into your calculator. And when you do that, your calculator should tell you 0.2448. Remember, we always give probabilities to 4 decimal places. All right, so we're still talking about our Americans with diabetes. It's estimated that 8.3% of all Americans have diabetes. That is our P. This time we're taking a random sample of 91 Americans, so that's N. What's the probability that the proportion of the people in the sample who are diabetic differ from the population proportion by more than 2%? So similar problem. Here's our 0.083. And we want to differ by 2%. So we're going to go 2% above that, which is 0.103. 2% below that, which is 0.063. And we want to know the probability it differs by more than that. So we want to go outside of this region. Okay, so that's what we're looking for. So when we do this on our calculator, we're just going to do one of the regions and then we're going to double it. So we will do 2 times whatever this normal CDF that we get. So when we do that, our lower bound, I'm going to do the lower end just because. is negative 1 e to the 99, negative infinity. Our upper bound is 0.063. Mu is 0.083. And sigma is the square root of 0.083, 1 minus 0.083, all over 91. And when we put that in the calculator tells us 0.2446. And then we're going to double it. If you already doubled it, then you don't have to do that, but we'll double it and we get 0.4892. So that is the central limit theorem with proportions, just a few adjustments, particularly to that sigma, and we can use this for both means and proportions.